Good morning, students. Today I'm going to explain another concept, location of roots with respect to roots of quadratic equations. See, in this I can prove 5 cases. So first our topic is location of roots with respect to roots of quadratic equations. See, let us see here. Y is equals to f of x, that is nothing but ax square plus bx plus c. In every quadratic equation has two roots, alpha and beta. Alpha, beta are the real roots. These are real roots. Okay, so first case, I can prove this first case when real number k lies between alpha beta. Observe clearly, when real number small k lies between alpha and beta. See, observe the graph. Here is x-axis and here is y-axis. Here is x-axis. So lies between alpha and beta, upward direction. The graph is upward direction. Here is alpha and here is beta. So here is always a greater than 0. A greater than 0, discriminant is also greater than 0. The graph is like this, upward direction. Okay. So for any real number alpha, when a real number k lies between alpha and beta. So in this alpha and beta, the real number should be here. Okay, k. See, in this k lies between alpha and beta, that point is here is f of k. Lies between here. Meet the y-axis. Okay, here that point is f of k. See, observe clearly. First, what we have to observe here, a is greater than 0 and discriminant is also greater than or equal also. Greater than or equal to 0, real and equal. And third point, what we have to observe, f of k is, here is negative y-axis. F of k is also less than 0. F of k less than 0. So here a into f of k is less than 0. Here is a is positive, and f of k is negative. When we multiply both, here is also getting negative. Okay, next downward direction, the graph like this. See, x-axis, y-axis, here is intersection of two roots alpha beta. Here is some point lies between k and alpha and beta. Here is k. This is nothing but f of k. So what we have to observe here, a greater than 0. Discriminant is also greater than or equal to 0. Third point is f of k is greater than 0. A into f of k is when, sorry, here observe clearly. Sorry, here is the graph is downward direction. A is less than 0. A less than 0. Okay, when a greater than 0, a is less than 0 means the graph is downward direction. Here a less than 0, f of k greater than 0, a into f of k is less than 0. So in this case, what is the common points? What we have to observe? Discriminant is greater than or equal to 0, and a into f of k is less than 0. These two are common. Okay. So, what is the common here in this? Discriminant greater than or equal to 0. A into f of k is less than 0 is common. Common points. Okay. Next case, what we have to observe, second case. In this case, I'm taking when the two roots are in the interval, when the two roots are in the interval k1, k2, k1 is less than k2. What we have to observe the graph? In this, here is a greater than 0. The graphs like this. Okay. A is greater than 0 and discriminant is also greater than or equal to 0. Here is alpha and beta, two roots. In the interval k1 point here, I'm taking k2 point here. The graph extend the graph. The point is like this. Yes or no? So this point meet this point is f of k1. Meet this point is f of k2. See, when a greater than 0, what is the points? A greater than 0 and discriminant is also greater than or equal to 0. Third point is f of k1 greater than 0 and f of k2 is also greater than 0. And one more, a into f of k1 is greater than 0. A into f of k2 is greater than 0. See, in this point here, one point x is equals to here minus b by 2a. Here x is equals to minus b by 2a. That point is nothing but minus b by 2a comma minus d by 4a is minimum point. Is minimum point. That point is minus b by 2a. So k value less than k1 value less than minus b by 2a less than k2. Okay, this one more point. And one more case, downward direction. If you take graph like this, alpha, beta, here is k1, k2. The graph, when extend this graph, this is k2, this is f of k2, this is f of k1. So this point is nothing but minus b by 2a x value, and this is nothing but maximum point, minus b by 2a comma minus d by 4a. This is nothing but maximum point. See, what we have to observe these cases here is also a is less than 0 and the next one is discriminant is also greater than 0. Real roots means discriminant is always greater than or equal to 0, and f of k1 is less than 0 and f of k2 is also less than 0. If a into f of k1 is greater than 0, both are positive, sorry, both are negative when we multiplying here positive. A into f of k2 is also greater than 0. So k1 value in the k1, k2 lies between minus b by 2a less than k1 less than minus b by 2a less than k2. So in this, what we have to observe the common here, discriminant is greater than 0 and a into f of k1 is greater than 0, a into f of k2 greater than 0, and k1 value lies between minus b by 2a. K1 is less than minus b by 2a less than k2. This is when the two roots are in the interval k1, k2, when k1 is less than k2. One more case, same here only, when the two roots are in the interval. Sorry, when next case, what we have to observe, next third case. When the real number k, less than the roots alpha, beta. only less than the roots alpha beta. Here I'm taking, here is the graph like this. Okay, here is alpha and beta. Here is some y-axis k. K value is always less than these two, alpha beta, always less than here k. See, here is nothing but f of k. So a greater than 0. First point is, in this point is minus p by 2a, and this is minimum point minus p by 2a comma minus t by 4a. See, let us see what is the point. A greater than 0. Next one is discriminant is not equal to 0. Next, f of k is greater than 0. And the third one is a into f of k is greater than 0. Next, k value is always less than minus b by 2a. Yes or no? K value is always less than minus b by 2a. In this graph, here I am taking k, alpha, beta, c. This is nothing but f of k. A is less than 0, first point. Second point is discriminant is greater than or equal to 0. F of k is less than 0. A into f of k is greater than 0. Last value, k value is also less than. Here is the point minus b by 2a. This is the maximum point minus b by 2a comma minus t by 4a. See, k value is less than minus p by 2a. In this, what is the common? Here, and discriminant is greater than 0. Okay, and a into f of k is greater than 0. This is also common points in this case. When the real number k less than the root alpha and beta. Next case, next fourth case, case 4. When the real number k, greater than, when the real number k is greater than the roots alpha and beta. See, in this graph, what we have to observe the graph like this. Here is alpha and beta. Here is a k. Here is the f of k greater than alpha and beta. See, in this point is minus b by 2a. This is a minus b by 2a comma minus b by 4a. Minimum point. See, in this, what we have to observe, a greater than 0. Discriminant is greater than or equal to 0. Next one is f of k is also greater than 0. A into f of k is also greater than 0. Next, k value is greater than minus b by 2a. In this graph, beta, alpha, here is some k. See, this is f of k. Here is a less than 0, first point. Second point is discriminant is greater than or equal to 0. Third point is f of k is less than 0. A into f of k is greater than 0. K value is also greater than minus p by 2a. So what is the common here? Discriminant greater than 0. A into f of k is greater than 0. And k value is also greater than minus p by 2a. Next, one more case. Fifth case. Case 5. So when exactly one root of quadratic equation, lies between, only one root is lies between k1 and k2. That means k1 less than k2. See, in this case, the graph, here is alpha and beta. Here is k1. Supposed to say here is k1. Okay. Here is some k1. Here is f of k1. So one root of the exactly one root of quadratic equation lies between k1 and k2. Only one, k2. Here is k2. So this point is f of k2. Okay, so here is what we have to observe. A is greater than 0. Discriminant is also greater than or equal to 0. Next, f of k1 is greater than 0. A f of k1 is greater than 0, f of k2 is less than 0. F of k1 and f of k2 here is less than 0. Okay. Next, in this graph, what we have to observe, here is alpha, beta. Here is some k, k1. Here is some k2. Okay. See, observe clearly. This graph is okay. Here is some k1. Here is f of k1. Okay. Here is a is less than 0. Discriminant is also greater than or equal to 0. Next, third point is here is some f of k2. Okay. F of k1 is less than 0. Next, f of k2 is greater than 0. Next, f of k1 into f of k2 is less than 0. In this part, we have to observe common points. Discriminant is greater than 0 and f of k1 and f of k2 less than 0. See, here are all the cases. Observe when k value is lies between alpha and beta. When k value is less than k1, k2 lies between the interval k1, k2. k1 value is less than k2. And next, third case is when the real number k is less than the root alpha and beta. Okay, when your real number k is greater than the roots alpha and beta, when exactly one root of the quadratic equation lies in between k1 and k2. All the cases, here is the location of the roots. Okay, thank you.